Hey everyone. So today in lesson 2, we're going to get started on different geometric shapes and looking at essentially their volume and their surface area. Okay, and we have a bunch of different shapes we're going to look at. Today we're just going to focus on prisms and cylinders. Okay, so the first thing I want to do is define for you what a prism is. A prism is a three-dimensional object with two identical bases connected with rectangles. Now, I want you to understand what the term base here means. Base doesn't necessarily mean at this moment it's on the bottom. If you take a look at this guy right here, okay, what's on the bottom of that guy right now is a rectangle, okay? But that's actually not the base of this shape. You have to remember that we can pick these up, we can rotate them, we can flip them around, okay, and get different views. And every time we do that, a different object is on the bottom. The base is the shape that kind of creates the whole thing. Remember, it said it's two identical bases, and then we connect them with rectangles. So if I look at this shape, the base, the thing that starts the whole process is this triangle here. I've got the triangle there, and then I've got the same triangle over here. And so those are my two identical triangles, and then I connect them with these rectangles in between. I've got one here, and then one kind of right there that you sort of can't see in the view, and then one that's the bottom, okay? So I'd have three rectangles connecting those two triangles. If I took a look at this next guy down here, well, that one is a little bit more familiar to you. You've been working with that guy a little bit more. He would be a rectangular prism, okay? So we've got a triangular prism that we did, and we have a rectangular prism that we did so far. Then if I looked at this last guy over here, okay, this guy is just the rectangular walls here, 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 and here that are joining the shape. The shape that actually makes it is this shape right here, which is a five-sided shape. A five-sided shape is called a pentagon. So we call that a pentagonal prism, okay? A pentagonal prism. All right, so for surface area of any prism can be found by determining the area of each face and adding all the areas together, okay? This is often referred to as the total surface area. There's not a specific formula for this. It's merely just unpacking all the different shapes that you see, okay? The volume, there is kind of a general formula for volume. It's this big B times H that you see below. The volume of any prism can be found by taking the area of the base shape, remember that's not necessarily the one on the bottom, and multiplying it by the height. Now the height assumes that you have the base shape on the bottom. So in that last example with the triangular prism, in order to get the height, I'd have to pretend that that triangle was on the bottom, so I'd have to rotate it like that, okay? So be careful, these words assume the base is on the bottom. Remember that the base is the shape that essentially makes the prism's name. So for this guy here, I just want to make sure you realize that that B refers to the base area, okay? Whoops, the base area. So make sure you don't look at that as just the base, it's the area of the base. So in that triangular prism, you'd have to find the area of the triangle. So then the area of the triangle can be found by going base times height divided by 2. So all those other formulas for like a triangle or a circle or a rectangle, they have to kind of kick in here, okay? All right, so let's try a few things together. First guy, John wants to fill up his rectangular pool, and he needs to figure out how much it will cost him. Now, if I'm talking about filling up a pool, am I talking about volume or am I talking about surface area? I'm talking about volume. So the pool is 8 meters wide, 12 meters long, and 5 meters deep. Okay, and then water costs $1.50 per cubic meter, and we're trying to figure out how much it will cost John to fill up his pool. So always start with the formula that you're using. We're trying to find volume, and we know that the volume will be the base area times the height. Okay, so that ends up being 8 times 12 times 5. 8 times 12 times 5 is 480 meters cubed. Now be careful with your units. Any answer that involves volume needs to have units cubed, and any answer that involves surface area needs to have units squared. You will get docked half a point if you don't have the right units along with the right exponent for that unit. Okay, any sort of length you do, then that's just one unit. There's no square or cube there. Okay, so now I know I need 480 meters cubed of water, and I know what it costs per meter cubed. So I'm going to take my 480 and multiply it by 1.5, and that gives me 720. So my conclusion, it will cost $720 to fill up the pool. Okay, awesome. Okay, a rectangular sandbox holds 32.4 cubic feet of sand. Are we talking about volume or are we talking about surface area there? We're talking about surface area. Okay, if the sandbox is 4.5 feet long and 3.6 feet wide, how high is it? So again, always start with the formula you're using, then you plug in the things you know. So the formula we're using is volume is the base area times the height. I know the volume is 32.4, so I'm going to replace my V with 32.4. And then I know the area of the base is 4.5 by 3.6, but I don't know the height. Okay, so now my algebra skills kick in here. I'm going to multiply 4.5 and 3.6 together, and that's going to give me 16.2. And then to get h all by itself, I'll divide both sides by 16.2, and I get a height of 2. Okay, so the sandbox height will be 2 feet. Look here, I have given myself units, and there's no square or cube there because here my answer is just a one-dimensional length. Okay. All right, a Toblerone bar comes in a box that's in the shape of a triangular prism with dimensions shown to the right. Determine the surface area and volume of the box. So we're going to do surface area first. I need to get the area of 1, 2, 3, 4, 5 shapes altogether, yeah? The triangle here, the triangle here, the rectangle here, the rectangle on this side that I don't see, and the rectangle on the bottom that I don't see, okay? I'm ready to get the area of the triangle. That would be 3 by 4 divided by 2, base times height divided by 2, and there are 2 of those. In order to get this rectangle here, though, I need this dimension, okay? So in order to get that dimension, I need to go back to this triangle, and I need to use the Pythagorean theorem, okay? Take a look. I've got a cute little right triangle if I kind of take that triangle and cut it in half. Okay, so I know that that's 4, and I know that this is 1.5 because it would have to be half of 3. So I can go 1.5 squared plus 4 squared equals my hypotenuse squared. Okay, so x squared equals 1.5 squared plus 4 squared. X squared equals 18.25. Now, that means x is the root of 18.25, and I'm actually going to just leave it like that. I don't want to write a decimal here because I don't want to run into any rounding errors, okay? If you don't like that, if that stresses you out and you want to write a decimal, that's totally fine. Make sure you're writing like 6 places after the decimal though, because you don't want to do any rounding until the very, very end of the question. Okay, so I already talked about the fact that I had 2 triangles. So I'll go 2 times base times height divided by 2, which is 3 times 4 divided by 2. This rectangle here, and this rectangle that would be like right there, those are the same rectangle, okay? So I can do 2 rectangles that are root 18.25 by 6, and then I have a bottom rectangle, and the bottom rectangle would be 3 by 6, okay? So I write all that out, plug it all into my calculator, and you should get an answer that's 81.26 centimeters squared, okay? 81.26 centimeters squared. Now, I want to do the volume. Well, to do the volume, it's the base area times the height. So remember, the base area would be the area of this triangle here. So if that guy is on the bottom, this guy here becomes the height. The 6 becomes the height, okay? So I'll go base area times height, which is 6. So volume will be my base area, which is the triangle. So that's 3 times 4 divided by 2 times the height, which is 6. That should give you 36 centimeters cubed. Okay, 36 centimeters cubed. Again, watch the units as well there. Okay, now a cylinder is essentially a special case of a prism. The base is a circle, and there is this one rectangle that kind of wraps around the circle in order to form the kind of can looking shape that we see, okay? So the surface area and volume is what we need to get. Let's start with this green diagram here and we'll get the volume. So the volume would be the base area. Well, the base area is a circle, pi r squared, times the height. So pi r squared h, okay? For the surface area, I have two circles that I'd have to get the surface of. So that would be 2 pi r squares. And then I have this wraparound. Well, I know that the height is right here. And I know that this has to wrap around the circle. Well, what's the distance around a circle? That's circumference. So that would be 2 pi r. And so what happens is the area of this rectangle would be 2 pi r h. And then we add to that the two circles, which would be 2 pi r squared plus 2 pi r h. Now, these formulas that I just wrote for you, they would be given to you on a formula sheet. They're not something you have to memorize, okay? All right, so let's put those into practice. Calculate the volume of a right cylinder to the nearest tenth if the diameter is 5 centimeters and the height is 12 centimeters. So you find the formula that you need. We're talking about a cylinder and we're talking about a volume. So I need to find the formula that says volume of a cylinder. Volume of a cylinder is pi r squared h. You were given the diameter, so that means the radius would be 2.5. Radius is always half of the diameter. So you have 2.5 squared and you have a height of 12. And you plug all that into your calculator and get 235.6 centimeters cubed. Okay, again, just watch your units there. Okay, a soup can, which is shaped like a right cylinder, has a diameter of 3.5 and a height of 6 inches. Now, what is the volume of the can of soup to the nearest tenth? We're talking about a cylinder. Volume of a cylinder is pi r squared height. Always write the formula you're using first, then you plug in the things that you know. So I know that my radius is 1.75 because it has to be half of the 3.5. And I know that my height is 6, okay? Multiply all that together and you should be getting 57.7 inches cubed for the volume of the soup. Okay, what is the surface area of the can of soup to the nearest tenth? So that's 2 pi r squared plus 2 pi r h. Again, r is 1.75 and h is 6. I can type all that into my graphing calculator and it will give me an answer of 85.2 inches squared. Okay, just make sure you're typing it in properly. Don't just watch me do this. Make sure you type that line in and make sure your calculator is saying 85.2. If you're not getting 85.2, you're putting something in wrong. So you just want to double check yourself that way, okay? I want you to get really comfortable with how you're typing it in your calculator. Okay, Jeremy has been asked by his school to paint a design on a cylindrical container that is going to be used for recycling cans. The container has a radius of 2 feet and a height of 3 feet. What is the surface area of the container that he needs to paint? Assume that he is going to paint the bottom, but there isn't a lid, okay? So if you think about that, that means there's one circle here that I don't need, okay? So the surface area of a cylinder was 2 circles plus the wraparound. I only need 1 circle plus the wraparound. So I said the surface area with no lid is 1 circle, 1 pi r squared instead of 2 pi r squared, and then the wraparound, okay? I plug in the things I know, and now I type that in my calculator. Make sure as well, I haven't said this yet, but it's probably a good conversation coming, especially from those of you coming from grade 9 right away. Pi is not 3.14, pi is the pi button. 3.14 is a horribly rounded version of pi, and if you use 3.14, it will throw your entire answer off, and you will get marked down for rounding error. Make sure you're using the pi button when you're doing this, okay? On a Casio, the pi button is your second function of your times 10 to the x button, which is on the bottom row. And on a TI, it's the second function of your exponent button, which is right underneath the clear button, if you can find the clear button, okay? So you should be getting 50.27 feet squared there, 50.27 feet squared, okay? Determine the height of a pop can that can hold 355 centimeters cubed of liquid and has a diameter of 6. Round your answer to the nearest tenth. So we start with the formula, we fill in all the things we know. We know we're talking about the volume of a cylinder, so that's pi r squared height. I know the volume's 355, so I'm going to replace my v with 355. I know my diameter is 6, so I can replace my r with 3. Okay, 3 squared is 9, and so I end up dividing both sides by 9 pi. Now, I need to talk to you about this. If you are a Casio kid, you go 355 and you can just say divide by 9 pi and you're totally fine. Okay, if you are a TI kid, the 9 pi has to be in a set of brackets. It doesn't glue the pi to the 9. And so if you don't put a set of brackets there, you're asking your calculator to go 355 divided by 9 and then take that answer and multiply it by pi. And that's not what you mean. So make sure 9 pi is in its own set of brackets. Okay, if you have done this correctly, you will get an answer of 12.6 when rounded to the nearest tenth. Okay, be absolutely certain you're getting an answer of 12.6, and that means you're typing it in correctly in your calculator. Okay, all right, the surface area of a cylinder is 225. The radius and the height of the cylinder are equal. Determine their measurements. Okay, so start with the formula that you know. Surface area of a cylinder is 2 pi r squared plus 2 pi r h. Now, I know that the radius and the height are equal. So instead of writing that h right here, this h here, if the radius and height are equal, I can just call it an r. So that would actually give me 2 pi r squared plus 2 pi r squared. Well, 2 apples plus 2 apples is 4 apples, so that's going to give me 4 pi r squared. Okay. Now, I know that the surface area is 225, so I'll plug that in for surface area, and I can solve for r. 225 divided by 4 pi, and then I would need to take the square root. Okay. So I did figure out what 225 divided by 4 pi is first. I get 17.9049311. In my calculator, though, I'm going to keep using that. So I'm going to use the answer button from here on in. That way I don't run into any rounding error. So when I take the square root of both sides and then round, I will have 4.2 as the radius. Okay. All right. The surface area of a cylinder is 5,234 centimeters squared. The radius is 15. Determine the height. So again, start with your formula. Fill in everything you know so that you can solve for what you don't. I'm talking about the surface area of a cylinder, so that's my formula for the surface area of a cylinder. Plug in 15 for r. Okay, now you got to be careful with this one. This is probably the hardest algebra I can give you in this unit. You need to see that this right here is just a number. And in order to solve for h, I'm going to have to get rid of that whole number, which means whatever that number is, I'm going to have to subtract it from both sides. Okay. So I just went 15 squared times 2 to get the 450. Now I'm going to subtract 450 pi from both sides. Okay. That's going to give me some sort of a decimal, and it's okay to work with the decimal there as long as you then keep using your answer button in your calculator. I'm going to divide by 30 pi. Okay, so 5,234 minus 450 pi is this 3,820.283306. Dividing by 30 pi, again, a gentle reminder, if you are a kid who has a TI calculator, you have to put the 30 pi in its own set of brackets. Okay, if you are a Casio kid, you don't need to worry about it. Okay, and then you should get an answer of a height of 41 centimeters when rounded to the nearest centimeter. Okay, good. All right, so I'm going to leave you be for now. You can try some questions on your own and come check in with me if you have any questions. Okay, in the meantime, have fun doing some math. Take care.